All right, let's give everybody a moment to catch up. Let me test that the audio is working for the video. Test 1, 2. Okay, audio's good on the video. Let's go ahead and I will open up chat. All right, so like I said, I went ahead and in the announcements incorrectly stated at first the chapters that were delayed, but I have gone ahead and pushed the quiz until Thursday because I wanted to go ahead and make sure you all had an opportunity to ask me any questions if they did arise from the chapters. I believe 7 and 8. Let me check. Yeah, 7 and 8. Okay, so I wanted to make sure you all had an opportunity to ask questions regarding that, and then also I wanted to talk about the big assignment that you all turned in about the design or architectural patterns, MVC, layered, and MVP. I believe that is correct. Is that correct? You can answer in voice if you want, if you're on the channel. Trying to work on more interactive forms of responsive forms of interaction. Okay, multi-tier. That's just the name. I think of it as just layered. But there might be a distinction there. So that's fine. Is who has questions or who wants to talk about that at all, or has opinions and wants to see if what you thought was what I think, things like that. And note, I want to state that none of the things I'm about to say are set in stone, because every time you try to apply one of these patterns, you might have to adjust the pattern to fit the platform or architecture that you're working on. So, for example, you might be using an MVC pattern, but it might not be a cyclical MVC. It might be a more linear, and we'll get to that distinction here in a second. Does anybody have thoughts or want to talk about the homework? Have opinions they want to express or question? Okay, Aaron, good. I'm glad you volunteered because you are alphabetically the first person in the list. So, what is your takeaways from the assignment, comparing and contrasting the three design, or we'll call them design/architectural patterns? Can't hear you if you are speaking. Aaron? Okay. Apparently we can't hear Aaron. Who next? Who else has a microphone? I believe Frank does. Is that correct? Sage does. Sage, would you like to go next, or Frank? Okay. What did you like about that? And how did you take away that they were changed? And for what reason? Okay. So that's one way of looking at it. So here's the canonical, or one of them, descriptions of model view controller. So here's a question. If you have a view that's complex, let's just talk about Android. Because I'll demonstrate this here. Actually, I'll probably do that Thursday, but I'll demonstrate a view and the controller. And unfortunately, in Android, these are sort of the same thing because of the nature of the platform. So that is a limitation that made MVC not as applicable in Android. But let's just talk about this pattern here. The controller can interact with the view and the model can interact with the view and the controller. Actually, let me make sure this image is canonical with the Wikipedia article. Okay, so here's the canonical picture. The model, controller, the view, and the user. And it has a fully rightward cycle like this. However, where does the user show up here is a good question. But the reason I bring up this reverse cycle is because, unfortunately, this is how it is actually implemented in a lot of instances. And then it becomes, okay, well, I need to update this view, when I update this view, where is that logic going to exist? Is it going to exist here, or is it in the controller, or is it in the model? You can put logic in all three places, and you can put logic in all three places that impact the view. So this is something you want to avoid at all costs. Does that make sense why you would want to avoid that? Go ahead, Frank. Let's try you again. Discord might be mutually exclusive or something like that. Yeah, we can hear you. Or at least I can, so they should be able to also. So does this make sense why you want to try to avoid this reverse cycle? Also, do you have a pair of headphones quickly available? No, that's fine. Just for future reference, it helps my voice not echo back when you hear it. I know, that's fine. Not a problem. Okay. What was your takeaway from the homework, from the comparison of the different patterns? Okay, that's an interesting thought. What happens if your small project starts becoming big? Well, that's a good answer. It sucks either way. I mean, there's no good. Like, that's one of those, oh, my project is scaling in scope and it is much more difficult than I expected. So what do you do scenarios? Sometimes that's good and often that's bad. No, real world is you just finish it the way you did and then incrementally change things often, not always. Take this grain of salt. You generally would finish with whatever pattern you were using, and then you would make new portions of the app in the other pattern, if possible. Because you can mix and match these patterns. That's quite common in Android and mobile and even web, where you have some web pages that are using this framework and another set of web pages are using that framework. Or in Android, you have one window that is a single fragment running recycler layout and another pattern called MVVM. And you might have that in Kotlin, and in another window you might have it in Java, and it might be using Model View Presenter. So you can mix and match portions of your application sometimes. Depends on what level of feature you're trying to mix and match, how integrated that pattern is into your overall complexity of the application. So here's a good example. Your login window and your login credentials, you're only going to have one of those systems in a web app or a mobile app, and you're just going to stick with it. And when you need to upgrade it or change it, you're going to just do it as a atomic action where you upgrade all the parts that need changed, and then you're done with it. And you make all the changes and you commit them in one major commit. Whereas, let's say you have a database on your device and you're writing, whether that be Java or Kotlin or Swift, you're on iOS or whatever the case may be, you are having a local database, and then you're going to transition to a library that helps you manage that database more easily. Well, at some point, you're likely to have both raw SQL queries and that library interacting at the same time. Does that make sense? How you would sort of slowly transition? And the worst part is you might realize, oh, this transition isn't actually working. Then you would go back and be like, well, maybe we need to do, okay, let's not do MVP. Let's do MVVM on Android or whatever the case may be. And you might then decide to transition to that, or lots of different options like that. That's called thrashing, basically. And it's something you want to avoid as much as possible, but there is no way to avoid it entirely, and the higher the degree you can avoid it is basically just how much programming and development and design experience everybody on the project has, and if the business requirements haven't changed during development, which is also quite common. Does that make sense to everybody? Okay. So, let's go back to let's draw. And everybody can see these pictures I'm drawing, right? They're readable, legible. What about the U at the bottom? Okay. Um, okay, good. Yeah, you're seeing the full screen. All right, so you have this architecture where you have a cyclical design, but actually, I think I missed. Oop, no. There we go. Yeah, the controller. There we go. User updates the model updates the controller updates the view, etc. This is an ideal solution because you don't have arrows going backwards. But how do you actually implement this is a good question. So here's the model. Okay, go ahead. Did I get that backwards? I might have. Oh, they are. It doesn't really matter. I mean, it does, but the flow of control wouldn't have changed. But yes, you are right. Yeah. Well, through the model and the user. So, that's sort of where I was getting to with this, where I was drawing, is you'll see the connection between MVC and MVP. Technically, there's more connectors, and there, whatever. But there's more connectors for MVP. But notice that your view, let me see if, yes, I can draw in different colors. Or check mark, whatever symbol you want. Notice the model and the view can talk directly in MVC. The model and the view don't talk directly in MVP, and I'm going to butcher the term they use. We'll just call it controller for now. It's not right. Multi-tier architecture. Sorry, I actually don't remember the terms that it likes to use for things. I think about these things more abstractly and visually like this as blocks. So here is the 3-tier architecture or multi-tier. And it doesn't actually show it this way. It shows it as 3 tiers layered like this. But when you actually develop this, what you do is you put the model, the data, inside the logic, like in the class of logic. And then you put the logic inside the presenter, which we often call the view. and then you start the presenter, and it launches in what's actually started by main, if we're in Java land. Does that make sense to everybody? Where the difference between the canonical drawing of this side here versus this is how it's actually implemented. Okay. Because I think it shows that the multi-tier is very similar to the MVP, except the naming, so presenter versus view, logic versus controller or presenter. Yeah, let's not have those letters next to each other. And then data versus the model. Now, these actually, when you look at them like this, basically the same. But, let's see. Sort of running out of space. But the presentation multi-tier is often thought of like this. You have the input goes to logic for the logic layer. You have the data, the logic layer, the data then changes the logic layer for the output. So, realistically, you can see how these are sort of implemented similarly. These two on the ends. And model view controller, how it's actually implemented varies dramatically based on what platform or framework you're using. I've never heavily used an MVC framework, so I can't think of how it's actually structured. But the thing I wanted to bring up is how it's presented as a flow like this versus how it actually is implemented might not look like each other. Nope. That's like this and this don't look alike. No, you don't want to say this. But they do represent similar workflows. Does that make sense? So the way you actually implement a lot of these aren't always going to match the theoretical design. So, for example, the model view presenter activity. Fragment. Actually, let's delete this. Mind you, let's highlight. These two are not ideal, but in Android sometimes they show up. So I'm not going to get into the details. Just magic hand waving, except that what I'm saying is true. Because there's ways of binding data to in the view to actual data, or binding the view presentation to the model information. It's much easier in the other pattern we talked about, but we're not going to go in detail, called model view, view model. But you can see how the activity, the fragment, and the views are all technically part of the view here. And that gets complicated. So the way you actually implement things, and the sort of the presenter is the fragment, or maybe you might make it a separate class, it gets dirty, basically. And so that's why the ideal implementation here isn't always how it's actually implemented in platforms. Does that make sense to everybody? That's one of the big things I wanted to get across to you all today. And we will go over code examples the remainder of the semester, basically, because we're basically done with the instruction material for this course. So the remainder 2 weeks, is that, I guess, week and a half? So the 2nd, the 7th, and the 9th. So we have 3 classes after this. All we're going to do is have review and discussion of topics to make sure that, like, this is a bunch of gobbledygook on the screen. I understand that. That's unfortunately the nature of drawing it out like this. But after you have seen this, and then I show you code, I will actually screenshot this. And we will talk about it more and compare it to other patterns, possibly. And then hopefully these will make much more sense to you all. I probably confused you more today. I apologize. But it sort of, I don't know if it needed to be done, but I think it's the best way to proceed so that we can show the strengths and weaknesses of all of these designs in real use. So, let's see. Does anybody have any questions? Go ahead. Yeah. Yeah, that's my point is this, like I said, I called it gobbledygook. Seeing it drawn out in and of itself, I don't think is super helpful by itself. But once we have the code and we can compare to this, I think it will be much clearer. It's surprisingly simple once you after I've talked about these like how this is how they're actually implemented. You would have a presentation, so you would have a main class and a main method in it. It would instantiate a presentation layer. That presentation layer inside of it would have a logic layer. That logic layer would have a data layer inside of it. So maybe that's not super clear to think of off the top of your head right now, but when we get to the code, it will become quite obvious. And this is the approach that I recommend people take for the final project. It's the most straightforward and simplest for your first larger project. And then understanding these other parts will help you with the concepts of why these patterns exist the way they are will help you in designing your other classes. We'll put it that way. So that you won't make hopefully won't make frivolous classes or frivolous methods in the classes, etc. I allotted more time for this class today for Q&A answers over the chapters, but if nobody has any of those questions, then we will go ahead and break here, and I'll give you more time to review the remaining chapters that we'll be covering, which is 7, 8, 9, and 10. I believe that is correct. Yes, 7, 8, 9, and 10. 7 and 8 will be quizzed on Thursday. 9 and 10 will be quizzed on the 7th of next week, and the exam 2 will be on the 9th. So I guess we'll only have 2 in-class sessions remaining. I'll be giving you out the written instructions for the final project also. I've been trying to make it as clear as possible and adjusting the difficulty for the remaining time so that you have enough time to work on it. So, if we, I think that's about it for today. So, that's 6. We've gone 2/3 of the class, roughly. If there's no further questions, I'll go ahead and give you the remainder of the class to work on this. studying independently, and we'll go from there. Chat. I'm not seeing any questions in the chat, so we'll go ahead and end there, and you all have a good evening.